the Small and Medium Ship Safety Forum will begin soon, so I kindly ask all participants to please be seated. We will now begin the opening ceremony of the Small and Medium Ship Safety Forum. Today's ceremony will commence with opening remarks followed by congratulatory addresses and a commemorative photo session. Good morning, ladies and gentlemen, and welcome to the Small and Medium Ship Safety Forum. My name is Myung-se-eun, and it is my greatest honor to serve as an announcer of today's meaningful event. It is a great pleasure to meet you all, and I sincerely thank everyone for taking the time to join us despite your busy schedules. This event will center on the two key global trends driving the international maritime sector: digitalization and decarbonization, collectively referred to as 2D. It will serve as a venue to share major countries' cases and jointly explore practical solutions to the safety and environmental challenges faced by these vessels. Today's forum brings together experts from both Korea and abroad who will share their valuable experience and knowledge. They include representatives from the Korea Maritime Transportation Safety Authority, KOMSA, Interferry, the University of the Basque Country, Spain, and the Danish Institute of Fire and Security Technology, the Norwegian Maritime Authority, and the Korea Research Institute of Ships and Ocean Engineering, KRISO. You can also participate in this forum through YouTube live streaming. During the live streaming, you will see 3 QR codes on the screen: one for downloading the program booklet, another for the satisfaction survey, and the other for submitting questions to each speaker. For those joining us on site, the same QR codes are available on the posters placed at your seats. We kindly ask for your active participation in both survey and Q&A submission. And we have also prepared souvenir for those who have submitted their satisfaction survey. And once you finish the survey, please present the screenshot to the registration desk so they claim your souvenir. Finally, please note that simultaneous interpretation is available for on-site participants. Channel 1 is for Korean and Channel 2 for English. Now then, let's begin the Small and Medium Ship Safety Forum. Before we begin the opening remarks, I would like to first introduce our distinguished guests who are with us today. Please welcome Mr. Dong-geun Lee, Executive Director of Maritime Transportation Division at KOMSA. Ms. Dorian T. Kabua, Deputy Chief of Mission from the Embassy of the Republic of the Marshall Islands in Korea. Mr. Bahati Lucas Masila, Minister Plenipotentiary from the Embassy of the United Republic of Tanzania in Korea. Mr. Chol Hong Kim, Commissioner of the Incheon Regional Maritime Safety Tribunal. Mr. Kyu-sun Choi, Executive Director of Strategic Business Division at Korea Institute of Ace to Navigation. And next, please welcome Mr. Sang-wook Kim, Director of Management Innovation Division at the Research Institute of Medium and Small Shipbuilding. We are also joined by 4 speakers from Denmark, Norway, Philippines, and Spain, as well as 12 senior officers from the Maritime Administration of 6 Southeast Asian countries who are visiting Seoul under the IMO Integrated Technical Cooperation Program. Due to time constraints, I regret that I cannot introduce each of you individually, but please know that we are deeply honored by your presence. Thank you. That concludes the introduction of distinguished guests for the 4th Small and Medium Ship Safety Forum. Now, I am pleased to invite Mr. Dong-geun Lee, Executive Director of Maritime Transportation Division from Komsa, who will deliver his opening remarks. Please welcome him with a warm round of applause.
존경하는 내 기빈 여러분 그리고 참석자 여러분 안녕하십니까. 해양교통안전공단 해양교통본부장 이동건입니다. 다시 한번 인사드리겠습니다. 올해로 4번째를 맞이하는 중소선박 안전기술 포럼을 개최하게 되어 뜻깊게 생각하며 이 자리에 함께해 주신 모든 분들을 진심으로 환영합니다. 우선 바쁘신 와중에도 이 자리에 함께해 주신 우리 해양수산부의 심상철 과장님 정말 감사드립니다. 그리고 인천의 해양안전심판은 그리고 주할 마샬 제도 대사관 그리고 탄자니아 대사관 아마 조금 늦게 오시는가 봐요. 그리고 노르웨이 회사청 인터페리 그리고 스페인 바스크 대학에서 오신 분들도 환영합니다. 그리고 덴마크 화재보안연구소 또 각국의 주관청 연수생 분들을 비롯한 모든 참석자 여러분께 깊은 감사의 말씀을 드립니다. 이번 제4회 중소선박 안전기술 포럼은 국제회사 기술협력 사업의 일환으로 해양수산부와 그리고 IMO의 지원 아래 한국해양교통안전공단이 주관하여 마련된 자리입니다. 중소선박 안전기술 포럼은 IMO 회원국 간 협력 강화를 통해 해양 안전과 환경 보호 역량을 높이고 특히 각국의 연안 중소형 선박에 대한 안전기술 발전과 지속 가능한 운항 환경 조성을 목표로 하고 있습니다. 우리나라를 비롯한 여러 동상의 국가에서 발생하는 해양 사고의 다수는 연안 중소형 선박에서 발생하고 있으며 구조적인 제약 그리고 장비의 노후화 그리고 선원의 고령화 기상변화 대응의 한계 등 복합적인 요인이 작용하고 있습니다. 이러한 연안 중소형 선박의 위기를 극복하기 위하여 이제는 대형선 중심의 기존 안전 논의에서 한 걸음 더 나아가 연안 중소형 선박의 현실을 반영하면서도 디지털화와 그리고 탈탄소화 흐름 속에서 새로운 정책적 기술적 해법을 모색하는 것이 매우 중요합니다. 올해는 바로 그 두 가지 축 디지털화와 탈탄소화를 중심으로 각국의 정책과 기술 적용 사례를 공유하고 중소형 선박의 안전성과 지속성을 높이기 위한 협력 방안을 논의하겠습니다. 또한 오늘 포럼에서 각국의 연안 중소형 선박 안전관리 정책과 기술 경험을 서로 공유하고 현장에서 실질적으로 적용 가능한 지속 가능한 해법을 모색하는 협력의 장이 되기를 기대합니다. 그리고 이번 논의가 IMO 기술협력 사업의 성과로 이어져 해양국 간의 포용적이고 균형 잡힌 해사 안전 발전에 기여할 수 있기를 기원합니다. 한국해양교통안전공단은 앞으로도 IMO, WMU 등 각국의 해사기관 및 학계 등과 협력하여 모든 선박이 안전하게 항해하는 바다 그리고 사람 중심의 지속 가능한 해양안전 체계를 실현하기 위해 최선을 다하도록 하겠습니다. 끝으로 이번 포럼을 위해 헌신해 주신 우리 해양수산부 그리고 IMO 관계자 그리고 모든 참석자 여러분의 노고에 깊이 감사를 드립니다. 여러분의 건강과 행운 그리고 소속 기관의 발전을 진심으로 기원드립니다. 오늘 이 자리에 함께해 주신 모든 분들을 다시 한번 진심으로 환영합니다. 감사합니다.
Thank you very much, Director Lee, for insightful remarks. And next, to celebrate the success of this forum, Professor Massimo Q. Mejia, President of the World Maritime University, and Ms. Dorian T. Kabua, Deputy Chief of Mission at the Embassy of the Republic of the Marshall Islands in Korea, kindly prepared congratulatory remarks. First, we will hear congratulatory remarks from Ms. Kabua. Please welcome her with a big round of applause.
안녕하세요, 여러분. 반갑습니다. Distinguished guests, ladies and gentlemen. On behalf of the Republic of the Marshall Islands, it is my honor to extend congratulations to the organizers and participants of the Small and Medium Ship Safety Forum, held as part of Korea's Maritime Week 2025. This gathering represents an important step forward in our shared mission to strengthen the safety, sustainability, and resilience of small and medium-sized vessels, particularly domestic ferries and fishing vessels that serve as lifelines for so many of our coastal and island communities. These vessels connect our people, they support our economies, and sustain our way of life across the Pacific. Yet despite their vital role, they continue to account for a disproportionate share of maritime incidents and fatalities. Forums such as this are therefore essential to advancing practical solutions that save lives, reinforce the foundations of maritime safety. The Republic of the Marshall Islands recognizes the great value of this forum as a platform for experts and officials to exchange knowledge, share innovations, and explore new avenues for cooperation. The focus on digitalization and decarbonization technologies, often seen as the domain of larger ocean-going ships, demonstrates how innovation can and must be adapted to meet the needs of smaller domestic vessels. This reflects the aspirational direction of progress we all seek, a maritime sector that is both safe and sustainable for all. For the Marshall Islands, and indeed for many other Pacific Island countries, today's discussions resonate deeply. The work being showcased here aligns closely with the mission of the Micronesian Center for Sustainable Transport, which strives to promote low-carbon, resilient, and inclusive maritime transport across our region. Likewise, it complements the IMO's Pacific Forum on Domestic Ferry Safety, reaffirming our shared commitment to strengthening domestic vessel safety through collaboration, capacity building, and technological innovations. We commend the government of the Republic of Korea, the International Maritime Organization, and the Korea Maritime Transportation Safety Authority, KOMSA, for hosting this timely and impactful event. The Republic of the Marshall Islands stands ready to continue working hand in hand with our partners to advance maritime safety and sustainability, not only within our own waters, but across the Pacific and beyond. 고맙다, 감사합니다, and congratulations once again on this successful forum.
We sincerely appreciate Ms. Kabua for your great congratulatory remarks. Next, we will watch a congratulatory video message from Professor Mejia.
Greetings from the World Maritime University here in Malmö, Sweden, and it is my great pleasure to join you virtually for the fourth session of the Small and Medium Ship Safety Forum. I warmly congratulate KOMSA for hosting this important gathering, which provides a platform for experts to exchange policy and technological insights to enhance the safety of small and medium-sized vessels. These vessels, such as passenger ships and fishing vessels, play a pivotal role in the lives of coastal communities and in bringing societies together. Ensuring their safety, therefore, strongly aligns with the aims of the International Maritime Organization, our parent institution. Recognizing this importance, the World Maritime University has long pursued education and research dedicated to the safety of passenger ships and fishing vessels. Our projects, including statistical analyses of passenger ship casualties, demonstrate our commitment. Several of these outcomes have been submitted as agenda documents to the IMO, sharing valuable insights with the wider maritime community. WMU and COMSA recently strengthened our collaboration through a Memorandum of Understanding signed on 18 March, focusing on the safe and sustainable operation of domestic vessels and the promotion of digital ship technology. We look forward to broadening this cooperation through joint research and related initiatives. In this context, this year's forum theme, Digitalization and Decarbonization, offers potential breakthroughs to unlock safer and more sustainable navigation of domestic vessels and to bridge the gap between these vessels and international maritime trends. Organized under the auspices of the International Maritime Organization and the government of the Republic of Korea as part of IMO's Integrated Technical Cooperation Program, this forum also supports member states in strengthening their maritime safety capacities. I wish the forum every success and trust it will provide meaningful and practical insights for all participants, including the invited officials from the maritime administrations of 6 ASEAN member states. Once again, congratulations to COMSA on the opening of this 4th session of the Small and Medium Ship Safety Forum. May the discussions here inspire further cooperation and tangible progress towards safer seas. Thank you.
Our sincere thanks to Professor Mejia for this wonderful message. Lastly, before we begin the main session, we would like to take a commemorative photo shoot with our distinguished guest of this forum. Distinguished guest, please come up to the stage for a group photo. Thank you. This concludes the opening ceremony of the Small and Medium Ship Safety Forum. We will now begin the session 1. Please take your seats. In this session, we will explore the theme digitalization, from data-driven decisions to smart safety measures. 3 speakers from both home and abroad will deliver their presentations, followed by a discussion on future cooperation. Before the discussion, we will also have a Q&A session after the presentations. If you have any questions during the presentations, please submit them using the provided QR code. Or if you are here on site, please feel free to ask your questions during the Q&A session. To begin the session 1, we will hear from Ms. Mary Ann Pastrana, board member of Interferry and chairperson of Archipelago Philippines Ferries Corporation. She will deliver a presentation on the topic, Interferry and FastCat, a journey to sustainable ferry operations. Please give her a warm round of applause.
Good morning. Distinguished colleagues, maritime leaders, and fellow champions of ferry safety, I am honored to join you today, home to some of the world's finest shipbuilders and maritime minds. As both a proud member of Interferry and chairperson of FASCAT, a ferry operator from the Philippines. Today, I bring with me the voice of 7,641 islands. I bring stories from communities where ferries are not a luxury, but a lifeline. I bring a journey, not just of vessels, but of vision, vulnerability, and ultimately victory. This is our shared journey to sustainable ferry operations. Let me start with Interferry, our global voice for ferry safety and sustainability. With over 270 members in 40 countries, Interferry serves as a vital bridge between ferry operators, regulators like IMO and ILO, and innovators across the value chain. We champion standardization of safety practices across diverse operating environments, advocacy for regulatory frameworks that are grounded in realities, support for domestic operators, especially in developing nations, and technology adoption that is both practical and cost-effective. As an Interferry board member, we don't just represent companies, we represent commitments to life, livelihood, and legacy. But we also recognize the hard truths. From 2011 to 2021, countries like the Philippines, Bangladesh, Indonesia, Congo, and Nigeria accounted for majority of ferry accidents globally. In my own country, the Philippines, we accounted for 7% of all reported incidents, mostly from capsizing and sinking. Yes, the trend in our country has slightly improved, but let's be honest, slight is not good enough when lives are at stake. The risks we face are multidimensional. Operational errors such as poor lookout or vessel modifications, technological gaps like outdated navigational aids or lack of redundancy, human factors from overloading to poor training, policy limitations due to fragmented oversight, and economic pressures where the cheapest option often becomes the default, even when it's dangerous. These are not just technical problems, they are cultural, structural, and deeply human challenges. At Interferry, our response is systemic and strategic. We launched the Ferry Safe Project, with country-level assessments and policy recommendations. This was held in the Philippines and recently in Africa, in two sides of Africa, in Tanzania and in Nigeria. We developed best practice safety standards and training guides. We built platforms for knowledge exchange like the one we're part of today. And we continue to promote affordable digital tools, empowering even small operators to level up their safety management. We don't just react to disasters, we prepare to prevent them. Digitalization has become the turning point. We've moved from paper logs and manual checklists to real-time alerts, predictive analytics, and integrated dashboards. It's not just about tech for tech's sake. It's about seeing a storm before it hits. It's about knowing when a part is about to fail. It's about making decisions based on data, not guesswork. This is how we save lives. Allow me now to zoom in the Philippines, my home, and the birthplace of FastCat. We are an archipelago of 7,641 islands struck by typhoons, about 28 in a year. We just had one, and there's one arriving. I saw today in the report from my office. Our country is served by 12,000 domestic passenger vessels, many of which are old and non-compliant. In these high-risk waters, FastCat chose a different path. We didn't wait for the crisis. We invested in solutions proactively, systematically, and sustainably. Over the last 12 years, FastCat has committed to safety as a way of life. We deployed catamarans built to international class standards. We engaged with partners and worked with the stakeholders like Marina, the Philippine Coast Guard. We advocate for women in maritime, world ferry safety, and Interferry itself. We contributed to the Ferry Safe project, offering insights from the front line. We standardized STW-aligned training, ensuring crew competence, and most importantly, we embraced continuous learning. Because safety is not an event, it is a habit. This is a slide that is a result of the Safe Mode research, EU-funded research, which FastCat is a part of. And I always like to share this because this is what we are adopting. It's called the safety learning cycle, wherein what is being taught is how do we capture our data or data capture? Do we analyze the data, or what are we doing to analyze the data? What did we learn from our data, or the safety learnings from the data? Did we have deep learning? Did we have a risk-informed design? And the cycle goes on in our operations and maintenance. And this is how we got to our safety learning culture. And this is what we are pushing for now. So, in having safety as a culture, the safety is not only in the design of the ship. You can see on screen one FastCat, that I think that's FastCat M19. So we considered the design of the ships, and it is a catamaran, lightweight, with aluminum. And again, as I mentioned, we value partnerships. We are involved in very safe projects, not only locally, but globally as well. We have standardized crew training, and we share our knowledge to forums such as this. We have digitized our operations through Vessel Tracker. This is a German technology that we use. ISTO for cargo stability, which is an Indonesian technology. We have digitized our online booking systems for customer experience. We have also used AI by our use of our national sales automation and preventive maintenance systems, and also used it for safety audits and maintenance. Each of these tools on their own are powerful, but together they form an ecosystem of safety. We operate 18 vessels across 8 routes, and we are happy to say that not a single life lost since we began. And we didn't stop with safety. We aligned our innovations with environmental performance. Our topic today would be decarbonization, and we have happily started our decarbonization journey using these carbonization strategies operationally, such as the use of Jotun paints or anti-fouling paints, and working with their research and development department, testing decarb technologies or air lubrication, adopting hullbot or robots in cleaning our hulls or autonomous cleaners, installing solar panels and wind turbines to power our bridge, because in today's world, safety and sustainability must sail together. But let me emphasize, digital tools must not operate in silos. When systems are fragmented, we lose insight. When data doesn't follow, people fall through the cracks. At FastCat, we built a unified dashboard where operations, safety, environment, and customer data all connect. This is the future. One view, one system, one culture of care. Our investments also support the IMO decarbonization targets. With the same systems, we track emissions, optimize routes, and reduce fuel consumption. We have just started and we have piloted this, and results can be shared over time. But what we want to say is that we don't have to choose between saving lives and saving the planet. We can and we must do both. As a close, I want to leave you with this thought. Safety is not built on policies alone, but by people who care enough to protect each other. Every safe arrival is a silent victory. Every ferry that crosses the sea safely connects not just ports, but families, communities, and futures. Let's keep working, not just for compliance, but for compassion. Let's advance together. Safety, innovation, connectivity. Let's build ferries that float, yes, but more importantly, let's build trust that lasts. From Interferry to FastCat, and from the Philippines to Korea, let's bridge the seas together. Thank you for your time, your commitment, and your courage. Mabuhay, kamsahamnida, and we will all sail safe.
Thank you, Ms. Pastrana, for your insightful presentation. Our next speaker is Professor Zigor Uriondo, Associate Professor at the University of the Basque Country, Spain. He will deliver a presentation on condition-based maintenance in marine propulsion systems, use case safer and more efficient fishing operations. Please welcome him with a warm round of applause.
Okay. Hello, good morning. I will start my presentation regarding condition-based maintenance. Okay. First, this is the index I will follow. Initially, I will start with context of application regarding mainly the fishing ships, and then I will follow with the rest of presentation. When we talk about fishing ships, I mean the main layout that we can find in the propulsion system will be a main engine with a gearbox, shaft, and the propeller. Sometimes, or many times, will be a controllable pitch propeller, a CPP, but many times will be just fixed pitch propeller. Other cases, the auxiliary generators will be engines driving the diesel generator, and on board we can have other auxiliaries like could be hydraulic pumps, etc., driven by electric motors or again other type of propulsion. Regarding something we can have a diesel electric, but it's not so common. Regarding fuel, we can say that diesel is the standard. In some cases we can have heavy fuel oil, and installed power could be from just some kilowatts to thousands of kilowatts, sail distance daily to weeks or even months, and from technology, from very simple to very complicated. So we are going to have a very heterogeneous layout on board. Okay, when we look at how mainly the engines and the vessels also are maintained, many times, especially with the smaller ones, what we are going to find is that they are not maintained, especially small engines. Maybe they could even not be repaired in whole life and just be replaced by a new one when they have accumulated thousands of hours. So if a failure is detected and they can wait, they will wait. Okay? Sometimes will be based in economical situations. The incomes are completely unsteady and depend fish prices, how much the catches, etc., etc. Also seasonal maintenance. So when they are not fishing, they will make maintenance. And in some cases, we are going to find that they follow strictly the maker's manual, that it's a safe way, maybe not the more efficient economically, but it's a safe way. So this means that in many cases, we are playing with risk. So if we want to improve, there are options. One of the one that here I come to propose is just to make better operation with condition-based maintenance. Okay, this is not really opposing, especially the maker's recommendation. This is in order to implement, to complement the maker's recommendation and follow what they say in order to do it. For this, we consider that the monitoring and digitalization is a completely necessary tool, it's a must if this has to be implemented. Well, when we go to monitoring usual fishing vessels or the engines that we can have on board, we can have very simple, the basic systems that could be from simple thermometers to pressure dial gauges, that they are not bad, but here we can have a strong human bias, because there maybe probably we are going to see someone 74 degrees, another one 76, another one 75. Okay, it's not bad, but if we want to follow a good trend and to make a model, maybe it's not the best. Other options, more modern options, could be digital monitoring systems that we are going to use electronic sensors like thermocouples, pressure sensors, etc. And the good thing that these systems can provide is the possibility of transmitting the data. So this data from these systems can be transmitted and integrated on board with several different systems. Okay, this will make data sets that later can be transmitted on board, can be recorded for historical data, and also will eliminate in many places this human bias in the time of looking at different sensors. Well, this is something that I consider, if we want to implement a condition-based maintenance, digitalization is a must. So we need it. Otherwise, we are not going to be able to assess a real condition. What we can find many times now, okay, handwritten data that are sent to the expert engineer onshore, and later this is compared with test bench data. Okay, basically we can call it an offline data monitoring by a source specialist. Well, drawbacks that this. Well, okay, the problem is that many times the data that we have from the factory were recorded in conditions that they are not repeatable on board. We are not going to have the same conditions in factory, in the test bench, and on board. So this will change many of the parameters when you compare with one from the other. This is not going to let us to follow a historical trend and see how the engines are changing. We are talking about that basic or strong maintenance is an issue of years, 2-3 years, 16, 20,000 running hours. And in this case also we can find that also the design is not exactly according to what was in the test bench. Here comes that recording data digitally can help because we are going to follow a history of the vessel and we can see how the values have changed. Well, as I said, main drawbacks of following or just looking at manual taking data that are later sent shore to replace them. Initially a delay. We are going to have a delay because data have to be written down, sent to the office, then someone in the office have to check this data, make an evaluation and reply. This can take days, weeks even, many times. Also, as I mentioned, human bias is the same people, is the same person, the one that is taking always the same data or is changing. Or maybe that sometimes, and I have seen experience many times, the data are just written down somewhere that is not in the engine room. Values differ from the test bench. This means that it's really, really complicated to detect trends. So it's very complicated to see how a metric is changing with time if the values are taken like this. And at the end, always an expert evaluator is required, which means a delay in the data evaluation. So many times when deviation is detected, it is already too late. It is already too late. And if it is too late, then we are hindering safety on board. I am talking about the propulsion system, but if we have no propulsion, the vessel cannot move. So at the end, this safety is extended to whole vessel. Well, as I mentioned, deviation is detected too late. What does that mean? In common situations, the problems will accelerate. So if some metric is increasing, let's say if one cylinder is suffering a fault, the problem will accelerate probably. It will become very fast. Maybe we cannot wait weeks or even or a month to have a reply. A small repair work, stopping on time, making some small adjustment could make big savings economically, but also in safety. This also means not playing long downtimes. Nowadays, stocks of spare parts are a problem, are being reduced. So if we are suffering a big failure, we can be stopped for long. And of course, if we lose propulsion, human life problem is on board. So we can see that monitoring can save. There are some vessels that, not small ones, I am talking about fishing vessels that can have complex ECR control rooms with many systems on board and good monitoring. This is an engine control of a fishing vessel, but still we still have that people on board, they are fishermen. So their main target is fishing. So sometimes they are not able to take care of machinery properly or as good as they would like, because they are very busy with other things. And just we can have people looking at sometimes data are not properly monitored. Okay, then we want to improve. We want a continuous evaluation of performance on board. And for this, the first thing that we need to know is what is a good condition of an engine. For this is where historical data can play a very important role. If we have recorded when the engine was new and how the engine was running, we have a signature of the engine, we have a picture of the engine in good condition, this could be compared. That's why digitalization is needed for a condition-based maintenance strategy. Challenge with this, first, monitoring system cost. We are talking about small fishing vessels. The monitoring system cost can be a very important part of the engine. A 6-cylinder small engine, I don't know, 60,000 euro. Monitoring system, 6,000 euro, 10%. Okay, 6-cylinder engine, same quantity of cylinders, same quantity of pressure sensors, but it is a big engine. Maybe the monitoring cost is just a 2%, 1% of the engine cost. So reducing cost and selecting properly the metrics is important. And then development the intelligence systems. We can make this picture of the engine, this signature of the engine, but who or what is going to decide that the engine is not as it was in the beginning? When it is a problem or it's just a small deviation that is not a real problem? This is maybe the biggest challenge, and still there is much work to do. For monitoring, cost optimization strategic, not monitor whole engine or select what to monitor. The people that we come from academia, we like to monitor and measure everything, but we must think that we are on board with systems that have limited costs. We can see this is an example of a high-end combustion measuring system that is fantastic, but just one sensor, the cost might be around 1,000 euro. And in a small engine, it's not possible to implement. So we must consider what we can do on board, not what we want to do. What can be done on board and what can be implemented. Okay, so just making a small summary. In the traditional system, we have engine, data are collected on board. If we exceed the value from an alarm threshold, we don't exceed, we don't make anything. If something happens, there is an alarm, we stop and we solve. What we propose is this data are stored. We develop a model, and this model later will run 24/7, controlling which are the data on board. And if there is no deviation, okay, we can run. And if something is occurring, if there is a deviation that we cannot call it as a normal deviation, okay, let's analyze, let's think what can be, plan what can be the next step. This has to be combined with the rest of traditional systems. So we cannot forget a visual inspection in the engine room. If a leakage occurs, something is happening, and a sensor maybe is not going to tell us easily what is happening. Vibration measuring system, follow with lubrication on oil analysis. The traditional system are there. So the target is not to replace people on board or systems that we have been using on board, is to complement, okay? Is to complement what we have. And for this, we have to develop models. Regarding engine modeling, just very briefly, we can have thermodynamic models that the first one use thermodynamic laws. If we can validate with this one with experimental data, it will be even more accurate. We can have commercial softwares that can do this with work. It's not easy, okay? But and this we can have it. Problem and drawbacks. First, detailed geometry of the engines in many times is not available. This is maker's information. We need the detailed inputs. The measurements have to be very good. Maybe on board they are not good enough. And computing time. Maybe one cylinder simulation can take days. So basically, they are very useful for research, but cannot be implemented on board. We should think another way to do it. Then we have data-driven models. So basically, we are talking about machine learning. And we talk about learn, we mean that we need historical data for that. Okay? So we are going to record historical data, could be locally or in cloud system, and with this we are going to develop a model. So again, monitoring and data storage are completely necessary. Regarding models, not going deep there, just mentioning them. The first one, the supervised learning, we have already faults. This is commonly used, especially in vibration machinery or rotation machinery, gearbox or pumps or whatever in bearings. They are even commercial systems, they are very good. And the other ones is that the unsupervised and semi-supervised learning, that we don't have faults. So for this, what we do is we model the engine in good condition because of the data that we have, the engine in good condition, and in this way, when we deviate for this good condition, we give an alarm. Which are the best methods or which are the best models to do it? It's an iterative process. Sometimes we have to test with data and select which are the best ones. So it requires work onshore, okay, and to make different evaluations. So then what we are going to have is the engine data, we store it, we cure the data, we develop a model, we evaluate it, and after evaluation, if the result is not good, we have to make it again. If the model is good, we implement it. Implementing means that we are going to obtain at the end, to make an idea, some coefficients, some values that later can be implemented in a simple system that could run on board. Okay, that could run on board. This is an offline process. It's time consuming, but nowadays even personal computers could be used for this, so it's not necessarily big machines for this. There we have an example in different steps. This is a project done some years ago. Okay, the first step is that we keep data. It was run for 2 years, more than 10,000 running hours. Then we cure the data, we select the data, and in the step 3, we make the model. And the final step, the last step, is that when we implement in a commercial software that it's LabVIEW, there we implement it and we keep it running on board in parallel with the monitoring system that is recording data. So target is we monitor data, we develop the model, we obtain data with the model, we compare them, and then if there is deviation, we inform the crew on board, or even we can send a trip, send a signal to the people on shore. In our experience, artificial ANN, artificial neural networks, are a good tool for this. There we have an example of a value in a test bench where with some inputs that are monitored, we can obtain several outputs that are regarding the engine performance. This is for test bench. So I mean, we are monitoring also emissions, several things. So this is just first step that we can later implement on board. And for implementing on board, we can reduce the number of inputs. For this, we need reliable data. So we have to select values that are measured constantly on board and will be measured constantly on board. Speed, torque could be also via the fuel oil rack or fuel oil index, or fuel oil consumption, that could be again also via fuel oil rack or fuel oil meters. Depending on the type of engine, could change the data we need. If it is a main engine, probably a speed will be necessary. If a speed is changing, with a FPP, fuel oil rack or fuel oil index, propeller pitch, if it is a controllable pitch propeller, and then if it's possible to install, and it's possible to install maybe regarding money, a torque meter or a fuel oil meter. In a diesel generator, speed is not a variable, it's not changing, always constant speed. So then fuel oil index or another value like charge air pressure. This will let us develop different, smaller models. Why? Some values should not change too much when, some metrics should not change too much when engine is in operation, because they are to be kept constant. Fuel oil pressure, lube oil pressure, cooling water temperature, etc. They have thermostatic valve or pressure regulating valves. So they are quite steady, and could be a distribution could be found that will tell us that more or less when we are close to the value that we should have. Smaller models could be developed depending on the subsystems in the engine, okay? Like we can have for the cylinder liner temperature or the iron exhaust there, that is a gas temperature in the engine. Values could be very accurate. Here we have values that we are the mean absolute error, that it's below 2%, except one of them, in one whole year. So the models could be quite accurate. This is not exactly the problem or the difficulty. The difficulty comes because the model could become quite, let's say, steady in the values. Okay, there's lines, but the actual one might differ in a daily basis, and it's not a problem. That's why trend and following trends is important. If we start deviating too much from the then there we are a problem starting, okay? Below we can see that two variables and you will not see the difference because the model is predicting it perfectly. So the difficult thing here is to define the criteria of when it is going to occur a fault. We are not talking about of an alarm level. No, alarm, there are already systems that are going to trip an alarm. We want something that is going to tell us before the alarms occur. Okay, and this is the difficulty, to define when this happens. Here we can see in 1 year, okay, one whole year, how many times one variable has gone out of the threshold. Okay, the next step is to define if this quantity is a problem or is not a problem. Okay, let's see it clearer with values that should be kept quite constant. Here we can see that between these two lines is within threshold, but sometimes some values there, they are just in the limit, okay, but just once. Next day, system went bad. Something happened on board, we don't know what, that went out to threshold, but it's not a real problem yet, okay? So expert evaluation is needed. To go in finishing, the models are not for always. If a repair work is carried out, the model can have some slight differences. And there we can see 2 years, 2020, 2021. Here we have 11,000 hours data, and the model is quite well, but from 1 year to the other, probably a refreshment of the model is needed. To finish, okay, there we have the engine. We have to monitor the engine. Then we make several subsystems. This is sent to server on shore. Okay, there we develop the model with different databases. You can see 2 years, 11,000 hours. So it's quite. Then we have the model, and we characterize the thresholds to define when we are going to start having a problem. And after this, the expert evaluation is needed. The question is that the expert does not need to be looking at the screen 24/7. There is, let's say, a trained engineer, not an expert, but a trained engineer developing 24/7. That is the the artificial intelligence. Finish. Historical data are needed, so monitoring and digitalization is a must. Okay, this will reduce operational cost, will increase safety, and also we still need human intervention to define the thresholds, and if the deviation is too big, to inform what is happening on board. And that's all from my side. Okay.
It was a great time to learn about the various information of propulsion systems and models. We sincerely thank to Professor Uriondo for your excellent presentation. Our third speaker is Dr. Yuna No, head of the Digital Convergence team at COMSA. She will deliver a presentation on data-driven approaches to maritime safety management. Please give her a warm round of applause.
Hello, everyone. Thank you for having me here today. And my name is Yuna No, and I'm the team leader of Digital Conversions team at COMSA. And today I'm going to share some actual practices on database approaches to maritime safety management and how we are applying AI technologies in this field, which is a hot issue these days. So the presentation will proceed in this order. And let me briefly introduce about COMSA and the efforts that we are applying for the digitalization. So as many of you may know, COMSA was re-established in 2019, evolving from the Korea Ship Safety Technology Authority, and we are now the only organization in charge of comprehensive maritime traffic safety management under the Ministry of Oceans and Fisheries. And our mission is very simple and clear. To secure maritime safety through accident prevention as well as operation and management of maritime transportation. And to achieve this goal, we carry out many different businesses, from the traditional business ship survey and passenger ship safety management, and to safety culture promotion and R&Ds on eco-friendly and autonomous ships, international cooperation, and lastly, data-driven safety management. And our entire safety management framework is now data-centered, as you can see in the middle. It's a big data platform, and it's designed as a feedback loop. So the causes and outcomes of accidents are analyzed like this and reflect back into our safety management process. And now let me introduce a key case of database management. Since 2021, COMSA has been building a big data platform for about 3 years, and we established an integrated big data platform that collects and analyzes a variety of data. And this platform doesn't just store data, it also performs a large-scale processing, including AI-powered analysis system right here, to turn raw data into useful information and public services. And currently, the platform connects about 30 systems from 10 different organizations in the maritime sector, including the Ministry of Oceans and Fisheries and Korea Coast Guards, and etc. And we collect real-time vessel position data from various vessel position transmitters such as AIS, VPAS, LTM, and as well as information on accidents, and vessel specifications, ship surveys, and marine environments, including sea weather. And we analyze, visualize, and deliver this information as public service right here to as a public service through the Maritime Transportation Safety Information System. We call it MTIS. And now we provide services through both web and mobile app. So MTS provides more than 20 services, and now let's take a closer look at some of the key services. This is infographic. So this infographic service provides visual summaries and charts of maritime accidents, so users can easily understand the overall safety status and trends. And this service shows various statistics on maritime accident, and this is not just a statistic but an interactive tool that allows users to generate customized statistics based on different factors like vessel type, accident type, or month, or season, and etc. So it's designed to make analysis easy and flexible for everyone. And Maritime Accident Keyword Analysis service analyzes 14 years of accident reports and identifies key causal factors by accident type. So it visualizes the relationship between keywords in a network form, right here, in a network form, so helping users to see how one cause leads to another. And for example, in the case of capsizing accident, seawater may enter the vessel due to high waves and leading to a loss of stability. Or in other case, if cargo is not properly secured, a sudden turn may cause the cargo to shift, and which can also result in a loss of stability. So like this way, even when the outcome is the same, the causes and outcomes are, the sequences are different. So by understanding these sequences, we can find the chain that leads to accident so that we can break it and intervene before accident occurs. And this service visualizes accident hotspots on a map. We utilize the hierarchical clustering, so as we zoom in, the size of cluster gets smaller, and we are able to see the specific locations of accidents. And it shows where certain types of accidents happen most frequently. For example, in road transportation, like cars, if there are frequent speeding accidents, then the installing speed camera would be effective. And for other cases, for areas with many pedestrian accidents, then the crosswalks would be the solution. So for the central and local governments, and their budget is always limited, this service helps them to implement the cost-effective prevention measures. And this service displays the current traffic situation in all Korean waters based on real-time position data. Around 100,000 vessels are registered nationwide, including 65,000 fishing vessels. Roughly 10,000 ships are sailing at any given time. So by analyzing vessel density, the system can calculate congestion levels and provide alerts for ships entering crowded area, so helping them navigate more safely. So now let me introduce PATIS, which is short for Passenger Ship Transportation Information Service. In Korea, every year, around 15 million people use coastal passenger ferries across Korea. And since 2020, ferries have been designated as part of Korea's public transportation system, but ferry traffic information had long been limited, even though weather conditions often cause cancellations or delays. So PATIS provides real-time ferry schedule, current vessel positions, and estimated time of arrivals for all coastal routes in Korea. So you can check the ship's location on a map and on the route diagram in the bottom. And you can check weather conditions and ticketing links. So this service has been integrated with big private map service company named Naver and Kakao in Korea. So most of Korean people use their navigational services, so travelers can easily find routes from the mainland all the way to the island, with all kinds of transportation connected, from buses, subways, and trains, and even to ferries. And this service predicts accident risks up to 3 days in advance based on weather forecasts, traffic, and past accident data. So this graph shows the changes of risk levels of the specific area as time goes on with a 3-hour interval. And we have improved our AI model step by step, starting from Bayesian neural networks, moving to MLP, which is multiplayer programming, and now we use EBM, which is explainable boosting machine. Then the area is divided into grid like this to visualize and display the predictive accident risk levels. So each area has different weather and fishing patterns and traffic density. So this system helps identify which regions may be risky in the near future. And this service is similar to the accident risk model, but it predicts future congestion level for each region. And it uses vessel position transmitter data combined with vessel size and weather forecasts to estimate congestion over the next 3 days. So this is the sample results of our model, and the left side here is the shows normal condition, weather condition, and the right side shows a bad weather storm. So using the AI model, which is trained with past traffic data, we simulated how traffic changes under these two conditions. So as time goes on, the storm approaches on the right side around Incheon and Busan port area. You can see offshore traffic drops while port congestion increases as vessels move into the ports to avoid the storm. So now let me introduce My Ship service. This service performs as a one-stop platform where seafarers and vessel owners can view all information about their ships at a glance. So it shows number one, it shows the basic information about their ships and vessel together with technical specifications such as crew capacity, main and auxiliary engines, and other installed equipment. And here, in the ship survey history section, users can check the most recent survey date, the type of survey, and as well as the next scheduled survey. So when the next survey date is approaching, then the system sends a push notification to remind the users. And number 3, it also provides the vessel's accident history. And 4, we provide 2 different safety ratings. One rating measure is traffic safety based on the frequency and severity of accidents, and the other, bottom here, the other shows operational safety, which considers the distance and hours of operation and how often the ship operates in high-risk areas. So these 2 indicators help owners easily understand the overall safety level of their vessels. 안 넘어가네. 됐다. 네. The trajectory history is another key feature. It displays the past trajectory records of each vessel, including locations, time, speeds, and routes. So ship owners can use this data to plan future operation or to improve in-house safety training. And finally, number 6, the system provides a real-time vessel monitoring service. So users can track the live positions of their vessel anytime. This is especially useful for companies that own multiple ships. Even from shore, they can monitor all their vessels so they can respond quickly in case of emergencies and check if any of their ships have entered danger zones, like where weather warnings or navigation alerts are issued. So in short, My Ship service provides vessel owners and seafarers a practical safety management tool, enabling them to take a proactive role in managing their own safety. So here's future direction. So as we move forward, AI is essential these days, and the universe of AI is huge, from robotics and computer vision to machine learning, neural networks, deep learning, and now here, generative AI. So far, Kumsa's AI applications have focused on more like clustering, fuzzy logic, MLP, BNN, which are more traditional forms of AI. But now generative AI is opening new possibilities. So especially in language-related tasks like summarizing, writing, or translating, etc. So these tools are already improving our work efficiency. But generative AI also comes with challenges, such as hallucinations, security, reliability, and cost. Still, one thing is clear, from the viewpoint of data scientist of myself, I think data is the foundation of all AIs. So let's say that the data is the ingredient, and the cooking is analyzing, and the cuisine is a service. Then in the past, the specialists like us cooked data into service. Now AI lets everyone create their own cuisine with a very convenient tool named AI. So in this sense, the most important thing is still high-quality domain-specific data. So Kumsa is continuously developing new AI applications with our data. So for example, users could simply ask in natural language that show me the vessel traffic flow around Korean waters. Then we can instantly see the visualized results without needing any specialized GIS or data science knowledge. And another case, we could simply ask, show all coastal passenger ferry routes in Korea, and the AI system will draw them. And then we can even say that overlay accident history on those routes, then I imagine that AI will combine them automatically. So this is the kind of interactive AI-powered data service that we are building for the future. So in conclusion, AI and data together are transforming maritime safety management. And at Kumsa, we are working to make our oceans safer, smarter, and more connected. That concludes my presentation. Thank you.
She introduced about MTIS and PATIS, main data program, which is developed from Kumsa. I think it is really critical to all of seamen. And then our next order, now that all three presentations of the session 1 have been completed. Next, we will have a Q&A session and discussion on future cooperation, moderated by Mr. Chung Jung Choi, Principal Researcher at Kumsa. I'd like to invite Mr. Choi and our three speakers to come up to the stage.
Chung Jong-choi from the Korea Maritime Transportation Safety Authority, and it's my great honor to serve as chair of Session 1. Discussion on the way forward for future cooperation. First, let me express my sincere appreciation to the distinguished speakers of Session 1. And today's session has focused on the safety for small and medium-sized ship vessels, delivering meaningful presentations on digital technologies and innovation about data-driven management. First, Ms. Marianne Pastrana of Interferry introduced sustainable ferry safety operation cases promoted by Interferry and FastCat. In particular, she highlighted cooperation between industry and international organizations to promote safety, standardization, technological innovation, and support for developing countries. In the Philippines, FastCat has applied digital safety management systems and eco-friendly safety and sustainability. I think her message, safety begins not from policy, but from the will to protect one another, reminded us that true safety starts with a human-centered culture rather than from technologies. Our second speaker, the Professor Zigor Riondo from the University of the Basque Country presented how to improve safety and efficiency of fishing vessels through AI-based CBM, condition-based maintenance. By shifting from reactive maintenance to predictive, data-driven management, we can prevent accidents, save fuel, and improve efficiency in operation. Like he emphasized, digitalization is not an option but a must. And he showed us that AI should complement rather than replace for human experience. Finally, Dr. Yunano from COMSA shared the institution's big data platform, AMTIS, and AI-based maritime safety management innovations. By integrating AI's weather, accident, inspection, and other data, COMSA developed a real-time risk prediction system and the MyShip service, allowing ship owners to monitor their own ship status. This demonstrates a move toward accident prevention centered and sustainable maritime safety management, not just simple technologies. In summary, all these presentations clearly identified the importance of digital transformation in ensuring safer operation of small and medium-sized vessels. We will now open the floor for questions. If you would like to ask questions, please raise your hand, and a microphone will be brought to you. Please. No question? Well,
I have a question.
yes, please go ahead, Marianne.
Okay, so since no one's asking, may I ask a question to Dr. No? They say Doc Yuna or Doc No. So I was quite amazed by your presentation about how advanced your data management is, and you are making it available to ship owners, operators. So my first question is it available for free to ship operators? Who populates the data? And how real time is the data? Like, how often do you populate it, and how often can they access that? Because in being data driven, that is one discussion I had with my flag state yesterday, and I was saying, okay, so where are we with regards to not being fragmented and not having silos with our data in the Philippines, so that Marina knows it, Philippine Coast Guard would know it, ship operators would know it, auditors would know it, and I think that is what you are doing. So that's my long question, Dr. Yuna.
Okay. Well, in conclusion, it's free. It's for everybody. Some services are for to the public, and some services are for the vessel owners or seafarers. They need to log in, actually, because they have private information, like such as vessel position data. So that's very private data, so they need to log in, but it's for free for everyone. And currently we have we operate this system for about less than 2 years now. So we have building it the platform for 3 years, and now we operate it less than 2 years, but almost 30% of the vessels are utilize this service. So at any time, so they can use it at any time, because the service is internet-based system, so they can just to log in, and then they can utilize the service. And the second question, what was that?
Because I think for the Philippines, we're now starting to populate our database. Just started by getting everybody in the workshop and asking in a voluntary status in filling it up. Did you have to undergo that? And was there any form of resistance from ship operators because of data privacy, or maybe the economic side, afraid of not declaring everything and stuff like that? Yeah.
Well, data privacy is very hot issue these days, so we have to very be careful handling those data. And the more difficulties during the building this platform was that actually when we try to connect all the data to make an integrated platform, because even though we have a statement in the law, it needs a common understanding between all the organization in maritime sector. So it was very difficult to having a common sense in data sharing. So that was the difficult.
But you did it.
Yes, it took a long time.
And it's now 2 years old. It's something I think we should learn from Philippines. Hello, my flag state's here. Please listen. How can we do this? And for our friends in Thailand, Indonesia, we were discussing about this yesterday. So I hope we learn from you. Thank you. That was amazing. Thank you, sir.
Thank you. Is there any question from the floor? Please go ahead.
Yes, my name is Young-Sik Kim from Korea Research Institute of Ships and Ocean Engineering. I have a question for Professor Uriondo. Can you suggest what is the minimum sensor set for using your artificial neural network system to estimate the health of the ship, the fishing boat engine? And then you mentioned about the cost effect for the fishery industry. What do you think? What is the minimum cost rate for using those systems in the commercially in the shipboats industry?
Okay. Here, can you hear me? Yeah. Okay, sorry. I mean, the question is clear, it's easy, the answer is not so easy. Why? Depends on the size of engine. I mean, the minimum I would say is just maybe 14, 15 or so temperature sensor, 2-3 pressure sensors. Why? One exhaust cylinder, 4 cylinder, 6 cylinder, 6. Previous turbocharger, maybe 2, 1, 8. Outer turbocharger, 9. Air temperature, 10. Okay, we can go increasing, but what happens if the engine is really small? If it comes, for example, from the industrial sector, let's say it's quite common to have industrial engine marinized, then maybe you are not going to find even room for so many sensors because they are more compact. Then you have to reduce, okay, before turbocharger we can. So this is what I mean, that the strategy has to be which engine I have, which is the minimum I can implement and will be better than anything. So nowadays, if it has an electronic control unit, there are already many sensors implemented on it. In such case, you don't even need to install them. Just have to communicate maybe a CAN or another digital protocol, so it's even easier. So that's why, unfortunately, it has to be done case by case. But I will go minimum for 5 with, I don't know, 2,000-3,000 euros, and also the cost depends, because regarding maritime industry, the costs are very different in Asia and in Europe. And a minimum, okay, will be something like this, okay? From a small to medium, there is not a progression. Sometimes there is just a leap. A medium engine, especially if it is classified, will have already a big set of sensors. So you don't need to expend money on it. You don't need to invest. You just have to deal with the data that we are already generating. Because especially with medium size, and if they are classified, they are already quite well monitored. So there's no need to invest in the sensoring. It's more the part of recording it, sending it, and dealing with it. It's very interesting that Dr. No said that they have in real time all the ferries, but also would be good to know if there is an alarm, there is a stop signal in a ferry, is this signal tripped immediately to the system? Or is someone that has to inform, no, the ferry is stopped? This is my question also. I mean, when we talk about digitalization, how we can put everything together, because at the end, IoT, and maybe the vessel is not integrated, and small things are already integrated. If in a small vessel the trip is immediately sent to some authorities that we have a stop in the engine, maybe it's nothing. Sometimes just go back, ask to the vessel, what has happened? Nothing. The sensor fault, but the engine is correct. Okay. But minimum, I don't know, depend. 2,000, from 3,000, for me, less than 3,000 euro will be impossible to start thinking about it.
Yes. Can I have a follow-up question, Professor? So you're putting sensors, fishermen boat, and what kind of competency must they have, and training that you must do and give fisher folks in order to appreciate digitalization and the impact that it will do for them?
I mean, some pictures that I saw, especially the one of this digital panel, okay, that was in a fishing vessel. I would say medium size, because the engine is 1,000 kilowatt. In such case, in fact, it is not needed to, let's say, make anything in the engine. The work is done. They have already the hardware on board. The only thing extra to be done is to put an Ethernet cable to something that transmits the data. shore. So basically, the hardware, most of it is there. So we need to take the next step. Okay, for training for them, basically most of cases they don't need special training for that. No, because they have to do what they have done until now. The only thing is that someone or something will tell them, look, in this cylinder, maybe something is happening. I mean, in the different steps of AI that we have seen, we are still in the very beginning. So we are not talking about generative, no. We are just in the very beginning. We are talking still, we are talking yet that we have to transmit data and we make a strong data sets. We are just in the beginning, okay? Then we have to implement it, keep it running, probably for years, because there will be many false negatives many times. And false negative means that you are not with a reliable system and the people will not trust on it. Okay, so then we are going to need years this system working. In this case, association like CONSAM might be very interesting because maybe it could be the place where the servers and the service could be provided. In many cases, especially for small fishing boats, that could be 1, 2 crew members, totally necessary for free because they cannot afford it. So.
Well, thank you for your response. And now we will take a question from our online participants joining via YouTube live stream and QR submission. Okay, I have a list for the question, and I will choose one. For this question goes to Zigor Riondo, and the question is that how does condition-based maintenance differ from traditional preventive maintenance in terms of safety and efficiency?
Okay, first we must understand first many manuals and instructions are provided to the people that take care of maintenance. If you get a manual for an engine maker, there you will have that every X thousand running hours, 10, 12, so many, disassemble the engine, open up everything. And many times you can see that they have a small remark, but depending on engine condition. So basically they are covering their backs, themselves, and go to the safer side. So let in the owner or in the operator side to extend the maintenance intervals. And the question is, why extend the maintenance interval if I don't know how the engine is? I think that the CBN could take a part on this. Instead of maybe repairing or exchanging parts every X thousand running hours, maybe increase a little this, and some parts extend the life, but maybe others, we have to reduce the life. So in this case, most of the time, extending the life because you know better how the engine is running. Mm-hmm. You have better insights to what is happening in the engine. So then you can try to extend the life in some parts, but also preventing in the small percentage of possibility of failure, reducing this percentage because you know better what is happening on the engine, and these abnormal conditions you are going to detect earlier in this way. Okay, and also in the case of fishermen, the first thing is one thing that we must know is the fuel. I mean, when we monitor, we are going to be able to know which is the fuel consumption of the engine. Just this, if you know the fishermen, this in their mentality makes them manage the fuel consumption, so manage the throttle. And this, in my experience, can bring reduction from 10 to 20% of fuel consumption easily, just knowing, because the vessel energy consumption is cubic. So it means that at the end, just a small speed means a lot of fuel. 10%, 10% speed, 25, 30% fuel. So just a small reduction. When they notice it, they just reduce the throttle.
Okay, thank you very much for your responses. And due to time constraints, we will now conclude the Q&A session. And before closing, I would like to invite each of our speakers to share briefly their reflections on this session and your suggestions for future cooperation in enhancing small and medium-sized vessels' safety. Please, yeah.
Yeah, so thank you very much for having me here, Komsa. Thank you for your hospitality, and I'm happy to meet everyone and talk to everyone and learn a lot. I have learned a lot. May I invite the other countries who have not yet joined Interferry? Please join us in Interferry. We're one happy family caring for the safety and international cooperation, technical cooperation, and we hold a seat, consultative seat in the IMO, thereby influencing policy making. So that's for Interferry. And for the rest of you, may I invite you also, if you have not gone to the Philippines, please come visit us. Come visit our 7,641 islands and make sure you ride a fast cat. Thank you.
I also enjoyed all the presentations, and then I learned a lot as well. And I think all three presentations converge on a common point that the real value of digitalization lies in turning data into safer decisions, and that is what true smart safety means. That's what I thought. And thank you for being here today.
Okay, for my side, it has been quite interesting to come here to talk, also to see some in some areas what is being done in Asia, because in Europe we have quite a close research environment with all the countries, but maybe not so open to other areas. So for me, it has been quite interesting to come here and to see, especially what is being done, some things. And thank you for inviting me.
Yes, good. I would like to thank all three speakers for your insightful and forward-looking remarks and practical suggestions. Today's discussion made it clear that innovation and collaboration and data-driven action are key to advancing the safety of small and medium-sized vessels. And the future of maritime safety as a whole. In particular, with many participants from developing countries and international organizations, this session has become a meaningful platform for sharing experiences and knowledge and promoting cooperation across borders. I sincerely hope that today's dialogue will serve as a starting point for continuous partnership and mutual learning among our countries. Thank you for your kind attention. This concludes session 1, discussion on the way forward for future cooperation. I now hand the floor back to MC Myung. Thank you.
Thank you very much. Please give a big hand to today's moderator, Mr. Choi, and our three speakers for their excellent discussion. And then this concludes the first session of the forum. We hope the first session was informative and valuable for everyone. Now we will take a 20-minute break and resume with session 2 at 11 o'clock. Thank you, and we will see shortly. Ladies and gentlemen, may I take your attention, please? We will begin the second session of the Small and Medium Ship Safety Forum shortly. Please take your seats. In this session, we will focus on the theme decarbonization, from policy support to practical application on domestic vessels. 3 speakers from both home and abroad will share their insights, followed by a discussion on future cooperation. And also, please note that this forum is being live streamed on YouTube, and simultaneous interpretation is available for on-site participants. Channel 1 is for Korean and Channel 2 for English. We will start in just a few moments. We will now begin the second session of the Small and Medium Ship Safety Forum. The main theme of this session is decarbonization, from policy support to practical application on domestic vessels. There will also be a Q&A session after the presentations. For online participants, please submit your questions using the provided QR code during the presentations. For those joining us on site, you may ask your questions directly during the Q&A session. And speakers are kindly asked to hold the microphone close to your mouth while presenting so that everyone can hear you clearly. Thank you. And next, the first presentation of session 2 will be delivered by Mr. Akalu Torbjørn Rue, International Program Manager at the Danish Institute of Fire and Security Technology. He will speak on the topic, Fire Safety for Future Challenges in Maritime Decarbonization. Please welcome him with a warm round of applause.
Okay. Thank you so much. Good morning to everyone. I hope everyone had a coffee or tea and feel refreshed. First of all, I would like to say thank you to Komsa for inviting and hosting this event and allowing me to be here and speak. My name is Akalu Rue. I come from the Danish Institute of Fire and Security Technology. In Danish, we short it DBI. The abbreviation does not make sense in English, but don't think about that. I would like to talk a little bit about fire safety for decarbonization in the maritime industry, specifically in relation to new fuels. Myself, briefly, I've been at DBI for 8 years, worked primarily with developing risk assessments for energy systems and for maritime use. For those of you involved in SSC and IMO, I'm also the lead author of CargoSafe. So if you're at the Fire Correspondence Group, I know at least one here, then I'm involved in that. Just briefly about DBI, I assume that most of you do not know who we are, since we are halfway across the world now. We are a Danish research and technology organization, also known as an RTO. We are a non-for-profit organization, which means that we do not earn profit. We reinvest all revenue back into R&D, and we are approved every 3 years by the Danish ministries. On top of that, we also sort of organize or sort of operate as a commercial company. That is to say, we do have commercial activities, but they are, as I said, reinvested back into the company. We have 7 locations in 4 countries, so these are office locations in Europe. But in addition to this, we are also present and do projects in Africa, in India, in Indonesia, and in Korea. A little bit more about DBI. We are a rather old company. We started more than 100 years ago testing roof felt for buildings, which is our sort of our origin story, you could say. We originate from the building industry, but now we also very prevalent in the maritime industry. Roughly 400 employees, 34 nationalities, and we serve 9,000 customers every year. We do state-of-the-art work. We work, as I said, with fire safety and security. We are approved by Danish government, and we are accredited. We have a fire testing lab. We also do fire investigations, safety inspections, and certification. We sit in a link between academia and industry, so sort of bridging that gap of knowledge between raw academia and practical application, you could say. We also do quite a bit of training and courses, standardization, regulatory activities, and collaboration with emergency services. DBI is engaged in safety throughout the entire process of shipping. So we can be involved in the design phase where we do fire tests for shipping products, maritime products. Could be walls or bulkheads or segregations, cables. We do simulation and modeling, and then of course we do a lot of scenario-based risk assessments. These will, as you can see, they go through all 4 stages. We're also involved in approval, compliance documentation, and we also do beyond compliance work. We're involved in operations. We analyze how things work and how they go wrong, both in terms of systems and machinery, but definitely also in terms of human factors. And lastly, we do incident investigation as well. Typical DBI energy and transport projects can range from anything from so simple as a fire plan, emergency management plans, to large-scale, multi-year risk assessments, training, guidelines, you name it, fire tests. We do most things related to fire. So I just want to talk briefly about why is Denmark interesting in terms of discussing maritime topics. Denmark, as you maybe know, is a relatively small country in Scandinavia, 5 to 6 million people, but we are quite leading in the maritime industry. We are driving ambitious regulations in IMO and the EU, chairing several and leading several of these efforts. Shipping is the biggest industry in Denmark. It's our biggest export. We're roughly 50 billion euro. And we do have a large maritime industry in Denmark. So most ships have equipment made and designed in Denmark, and half of all waterborne transport in the world is driven by a Danish-designed marine engine. These are a few examples of some of the green transition projects that we see. So these are mostly moving to new fuels. We have a range of domestic ferries, smaller ferries that have gone fully electric. We have this one, which is quite interesting, which will be the world's largest electric ferry when it rolls out in 2028, I believe. Another example, a smaller domestic electric ferry, offshore charging points, and a fully electric tugboat from Switzerland. So I would like to talk a little bit about how DBI is involved in the maritime regulatory efforts in terms of decarbonization. We work and assist with the Danish Maritime Authority, where we provide technical expertise and research-based input in relation to fire strategies and safety aspects for new green fuels, also for container vessels, both smaller but definitely also larger ocean-going ones, and testing standards for development of future-proof requirements for green fuels. We're also engaged in developing standards, both nationally and internationally, on EU and IMO level. And we are currently involved in developing the bunkering standards for methanol and ammonia. So our role in the safe implementation of the green transition is to support it fast. It needs to move fast. We know that this is needed, but it also needs to be safe. And I would like to come to the point of safety and talk a little bit about the challenges with some of these new propulsion methods. So what is the issue? You could say marine regulation, like most regulation, moves a bit slowly. Some of you are probably aware. Technology tends to move faster than regulation can keep up, and this provides some challenges. Authorities need expert knowledge, and we are here to provide that. So we assist the DMA, we assist the IMO, and we assist industry in navigating where regulations exist and where there are holes in said regulations. We have a project called MetaFuel that aims at producing an overview for stakeholders to identify applicable regulation and where there are holes in the regulation. For example, where you need to use other IMO instruments instead. Batteries. Batteries is an interesting topic when it comes to decarbonization. It seems to be the major driver, especially for small and medium-sized domestic vessels. In a marine context, they're interesting. They can either be the propulsion system, the main propulsion system. They can be a supportive propulsion system, but they can also be transported, both in terms of passenger vessels, but also container vessels, for example. They can be transported new. They can be transported used. These are two very different risk scenarios. And when failing, batteries can often lead to a fire, and unfortunately sometimes they also lead to an explosion. For fire, as it stands right now, IMO works with the ISO 834 fire curve. That is, to put it mildly, probably not very representative of a battery fire and how it behaves, which is an issue. So to go beyond these codes, a lot of work is being done also by the class societies, but to go beyond these codes, we went to test because reliable test data is not really present. So we built a mobile battery test facility. Why mobile? Because we don't want to test batteries at our current fire lab because of the explosion risk. So we don't want to have it near our premises in Copenhagen. So if we do small scale stuff, we can test it here. And if we do explosions, we can move it somewhere else. This is an example where we test on very basic cell level inside MOBAT. It's a small-scale testing, and it shows the off-gassing of the battery, and then it leads to initially or sequentially a fire. And the test is carried out in collaboration with the Danish fire brigades to create some knowledge and upgrade their fire safety strategies. We also do explosion tests. So the test here, so here we're moved off-site because of the explosion. The test is aimed at understanding conditions that leads to a lithium-ion explosion. It's made to inform the designs and what conditions should be avoided. For example, stuff like this could lead to new ventilation requirements. I guess that's something Arne and I can discuss at length. So essentially it's to recreate reliably explosion conditions so we know how to avoid them. We also did a project called ELBAS. This is focused on handling EV fires, so not for batteries as a propulsion method for the ship, but for the risks that comes with carrying electric vehicles. The project was aimed at sort of creating a realistic test setup for various extinguishing methods with an electric vehicle in the middle, surrounded by 8 other vehicles in a very low ceiling environment, representative of a full car deck. We tested various tools. Some performed well and some performed less well. Let's say it's extremely difficult to control these fires in this kind of environment. The report is publicly available, and there's a YouTube video as well for those interested in seeing it. Then I would like to talk a little bit about fire challenges for methanol. Methanol is another one of the you could say, green fuels that seem prevalent for small and medium-sized vessels. It's at least more interesting than ammonia, at least for now. The thing is, methanol also carries certain challenges as the batteries. Methanol is an alcohol, and it behaves quite differently than diesel does when it burns. If you look at the top picture, both pans are a fire. The left one is a methanol fire, and as you can see, you cannot see the fire in daylight. And the right one is a diesel. And as you can imagine, that can be quite challenging, both for detection but also for firefighting, for sailors who cannot actually see that something is burning. It is used as a fuel now, but not widely, so it's quite a step up for most industry stakeholders. And current regulations and guidelines lack specific guidance. Another thing is that there is really no reliable fire suppression method for methanol in the maritime industry. The testing standards for liquid fuels include strict limits on weather conditions that are maybe not realistic for maritime use. And the question also begs itself, what do we do with large storage at port facilities? So just briefly for fire detection and suppression, for methanol, what is the right method to actually extinguish methanol on board a ship? Well, the problem is that we're doing quite a few projects on this to determine the best methods. The images you see are, the top one is the burning freely, and the second one is after a water mist activation. And as you can see, it does not extinguish the fire. It dilutes it, but to dilute it enough will take a very long time and will not be very effective. So the idea with these projects is to mobilize the ecosystem to identify practical, usable ways of extinguishing methanol fires and mobilize regulators, class shipyards, and operators to find solutions to this. As I said as well, Methanol storage at ports for bunkering is also currently a challenge. It's a regulation challenge for many. It's a showstopper because they cannot document the correct or satisfying safety levels. And right now it entails quite a higher cost than regular fuels. Lastly, I would like to talk about hydrogen. As many of you know, hydrogen is also an interesting green fuel, especially it's sort of the first step in developing methanol and ammonia anyway, so for smaller ships it can be relevant. Unfortunately, hydrogen poses different safety challenges. Most elements are not so great in terms of fire. It's highly volatile, highly reactive, and it burns very fast. It also explodes very easily, and it sips through materials, so there are quite some challenges. Most calculation tools available right now are based on large open-scale scenarios, which are not representative of ship interiors, so this is problematic. Hydrogen is also extremely difficult to model in fire modeling and explosion modeling because it is highly reactive, and we do see industry-wide and academia-wide uncertainty in pressure measurements that are currently not under control, which is quite problematic, to be fair. And you could say, in general, when hydrogen systems fail, they result in one or two outcomes. They either result in an explosion or a jet fire. So naturally, we are testing for those. So we have a program currently doing hydrogen explosion testing, and we've also carried out various jet fire tests, both in open air and with obstructions. And naturally, when you have obstructions, you see the jet flames behaving quite differently. Usually, they become longer when they run along a bulkhead or hit obstructions. So hydrogen training, and I would say training is going to be a topic for any of these methods of propulsion, but for hydrogen maybe especially, is paramount for seafarer safety and for passenger safety. Fire education is quite a small part of crew training in general, as most of you probably are aware. If you talk to professional firefighters, they have very little regard for seafarer firefighting abilities, and I think that is something we as influencers in the maritime industry need to remember, that seafarers are not necessarily firefighters. It is not the primary task of their being. The primary task is to operate the vessel, and maybe some of them will never see a fire. So the level of experience in dealing with fires is vastly different from a professional firefighter. So training is quite necessary, and especially with these new fuel types that require different ways of thinking, different procedures, and so forth. This one I will skip. Lastly, before the end, I would like to touch on a little bit on new technologies for fire detection, because this is also something that is quite relevant. We in DBI are contributing to the improvement of international fire detection requirements. We're working closely with IMO on this. Recently, we developed a full-scale test container, and this has been used on ocean-going container ships to test new detection methods for hold detection systems, but it could also be used for on-deck detection systems. And of course, it could also be used on smaller or medium ships, in domestic waters, for feeder ships, anything that carries a container. It could also be used on a truck that would carry a container, for example. And the container basically simulates the early onset of a fire and enables testing of very early detection. So conclusive remarks. Does maritime decarbonization lead to a higher fire risk? Initially, you look at it and you would say yes. I would say ideally not necessarily, but it will take work. It's not easy. And the key takeaway here is that it's not a one-to-one process going to new fuels and propulsion systems. You cannot just copy what we did with diesel and the systems that we had and assume that things are going to be the same. they will not be the same. Then we have a problem. We have to acknowledge that there are new challenges, and we have to acknowledge that we have to work on how to deal with these. They can be mitigated, so we have to change systems, procedures, training, and we need to have new knowledge, both basic knowledge, and we need to provide new knowledge to the operators and the seafarers. And we are here to assist with that. Then, I would like to say thank you. We believe in a safe and fast green transition, and that's it for me. Thank you so much.
It has been a valuable opportunity to learn about DBI's remarkable achievements, such as fire safety challenges. Thank you to Mr. Rue for your excellent presentation. And next, we will have Mr. Arne Brathol, Senior Surveyor for Passenger Vessels at the Norwegian Maritime Authority, who will deliver the second presentation. He will speak on the topic, 10 years of ships with large battery systems, facilitating experiences and regulations. Please welcome him to the stage with a big round of applause.
Yes, so first of all, thank you to COMSA for inviting me, and it's an honor to come here. My first time in Asia, it's been a new experience for me. I was talk about our experiences with batteries, and that is sort of what I've been doing at the Norwegian Maritime Authority for the last 7 years, working with battery safety. So before I started at the NMA, there was the first battery ship, or fully electric ferry. It was the result of a national tender. Basically, most of our ferries, or almost all of our car ferries, are part of the road network. It's a public tender saying that this ferry should be fully electric. We did a IMO Circular 1455 process on this vessel together with DNV. Helped immensely on this. It had it still operates today with 1 megawatt-hour installation. Started operation in 2015. And it still operates. The batteries, the latest we have heard is that they have 2 more years to go. They were originally designed to only last 10 years, but they have been checking the state of health, and it should be able to go further 2 more years. A fun fact about this crossing, it's about 20 minutes, and the average cost of the crossing is about $15 in energy for the entire vessel. So Ampere, the first fully electric ferry, has been really a success story. So after Ampere, everything sort of exploded. Today we have over 100 ferries that is at least hybrid capable. Many of them fully does their journeys fully electric. In total, with Norwegian flag, we have over 350 ships with some sort of a large battery system installed. And so today, 30% of the public ferry crossings are electric. And again, it's the Norwegian Public Roads Administration who is the largest contributor to that, saying in their tenders that the vessels need to be electric. For the more private enterprise, for fishing vessels, they can apply for a support scheme that is run through a company called Enova, which is owned by the government. And Enova does a support scheme for all environmental friendly programs. If you build your house, you can get money for solar panels and stuff like that from Enova. So today, their scheme for zero-emission battery ships is that you can apply, and they can cover 80% of the increased cost of the building, as well as 60% of the cost of charging facilities. So as a private entity, you can apply for this. They also do support schemes for other environmental friendly programs, ammonia, hydrogen, and also if you have something groundbreaking that is not yet defined, you can apply for money support. So where do we fit in? Our sort of focus is safety. And we always start with this phrase that alternative power sources shall have equivalent or better safety than a conventional ship. But we need to be realistic here. A hydrogen ship or an ammonia ship, it will not have the same safety level, even a battery ship, as a diesel ship, because you've introduced an explosion hazard for hydrogen that wasn't there before. So what we are looking for is an acceptable safety level. And what we are trying to do now, 10 years after the first battery electric ferry, is trying to facilitate this way into an acceptable safety level for the batteries, or for large battery installations. So after Ampere, DNV had their first class rules, prescriptive class rules, published for battery installations. Shortly after they were published, there was an explosion in Sweden during a testing of a battery system. And this explosion sort of uncovered some flaws in the current rules. So the NMA decided that we needed to come up with some guidelines to handle that explosion risk that we saw. We were helped by Norwegian Defense Research Establishment, which had been working with lithium-ion batteries since the 80s. And what we had to see is that in our building regs or in SOLAS, there's no prohibition against lithium-ion batteries. So we had to go into our act, which says that a ship should be designed to have a sufficient safety level. And with this explosion risk, we saw that we needed to do something more than what was in the regulations or rules from the class. In 2019, one of our ferries had explosion following a battery fire. There was an external fire heating multiple cells into thermal runaway. The fixed fire extinguishing system really didn't do anything at all. It actually worsened the situation. And then also they had this saltwater last resort system that also escalated the situation. We were lucky. You see this hatch here. Basically what happened was that the fire or the incident was going on throughout the night, not really that much happening. The fire department was there doing the temperature checks throughout the night, and then in the morning they opened that hatch, went back on shore. 2 hours later, just as they were going to go down the battery space, the explosion happened. So if it happened 5 minutes later, then the firefighters would have been going down that hatch. So really lucky, and we learned stuff from it. So DNV, or our class, updated their class rules following the incident, and we were happy with those changes. We focused on crew competence, which we saw was lacking. Crew competence, what to do in the situations, and also the safety of first responders. So we, together with the Norwegian Fire Department, launched a program to improve knowledge and training in the fire departments. And also we published guidelines for minimum training of crew on board ships with lithium-ion installations. That was following the Ytterøyningen explosion. So today, if you're a seafarer working on the ship, you need to have specialized training. And I think the NMA is the only country requiring, or have at least published, these kinds of training requirements. In 2021, we had another incident, which was a small passenger vessel called Brim, which was an electric hybrid. This ship had been going on all day with school children. And when they were done with their final trip with school children, they were going to relocate the vessel, and that's when the fire broke out. So again, really lucky. It was towed to port, and the fire brigade, fire department took their learnings from the Ytterøyningen incident, realized the explosion hazard. Instead of just ventilating the room out, they used 7 days to try to connect hoses to the room and flush the battery space with nitrogen to avoid allowing oxygen to come into the room and create an explosion hazard. So the battery space was destroyed. This is the picture of the battery space. A lot of smoke and corrosion damage in the adjacent spaces. But even though the fire lasted for a really long time, this is an aluminum build, there was no fire spread to other areas. So we see this as a possible best case scenario if you have a battery fire in a battery space. After Brim, the cause was that there was a lack of ingress protection on the battery system. So the battery system didn't really have any ingress protection at all. There was saltwater intrusion into the room, leading to shorts, which heated multiple cells into thermal runaway. So we have published a safety notice on that. I know Korea has had some issues on land-based installation close to the sea, which also struggles with salt and moisture. Now the rules are changed. You have to have at least ingress protection of a minimum of 44. So these systems would not be allowed on new builds today. We also did some work trying to find an acceptable safety level for the vessels less than 24 meters. This was because Enova, without telling us, suddenly came up with a program where you as a fishing owner or a small cargo vessel could apply, use 15 minutes, and you get millions of euros in support. And we didn't have any rules for these vessels yet. So that's why we had to make guidelines for these types of vessels. We are a bit stricter on what type of battery system that is allowed on this vessel, and then there's a more leniency on the vessel itself compared to a larger or soulless vessel. So after the Brim incident, DNV did a large update in their class rules based on safety recommendations from the investigation authority in Norway. When we look at the different class rules today for battery installations, it is our opinion that the DNV 2023 rules they have gone beyond the other class. So it is our feeling, or is our opinion, that regulations for Norwegian ships is necessary to maintain the same level of safety independent of which class society is chosen. So, before this summer, we came up with regulations, a proposal for regulations. They've been on public consultation. We are working through all the feedback. There was a lot of feedback. But we are working through that. And hopefully, if we get the industry along with us in Norway, these regulations could function as an input to IMO for regulations for these types of vessels. This will be above 24-hour SOLAS vessels then, but we are in the same regulations incorporating the published guidelines for vessels below 24 meters. So some of the reactions to the proposed regulations, we had a retroactive requirement in there saying that when you changed your battery system or bought a new battery system, and latest within 10 years after the regulations came into effect, then the vessel needed to follow the regulations. We have gotten some feedback that is very problematic. So that will be changed. We cannot do retroactive requirements in the scope we wanted. We are also limiting some of the types of battery systems that is on the market, saying that they cannot be installed on the Norwegian flag vessels if they follow the regulations. So obviously we have gotten reactions on that because a fair bit of the market falls out of the Norwegian flag vessels. There's always, when you make regulation, a desire for more technology neutral. And I'd say that there's always an alternative way to regulations. There's always a way to make alternative design, and that is the technology neutral way. The way we propose our regulations is that we have done a lot of work creating regulations that we are of the opinion of create an acceptable safety level. And that is for the majority of the users. There's always an alternative way, but if the regulations are technology neutral, it doesn't really provide that much worth to implementing this on a big scale. And of course, the high-speed vessels are concerned that every safety aspect we put on is increased weight. So we have a lot of concerns coming back from the high-speed vessel section, and we are looking into that, what we can do to accommodate the high-speed section. Okay, so that was it for me. Thank you.
Mr. Brathel introduced various case of incidents followed by an analysis. I think it has reminded us to stay alert and awake. We sincerely thank to Mr. Brathel for your insightful presentation. And next, we will invite Dr. Jun-gon An, Principal Researcher at KOMSA, who will deliver the third presentation on the topic, Policies Promoting the Adoption of Eco-Friendly Domestic Vessels in the Republic of Korea. Please welcome him to the stage with a warm round of applause.
Good morning, everyone. I am Jun-gon An, working for the KOMSA, Korea Maritime Transportation Safety Authority in Sejong City. First of all, I would like to tell you how honored I am to have this worthwhile presentation during this program. I sincerely welcome all of you to visit to Republic of Korea. I believe your enthusiastic activities may contribute to following the pathway to net zero during the Korean Maritime Week. My research was regarding liquefied hydrogen tankers fuel cell-based propulsion system, I'm still doing my research on green ship technologies as well as green shipping corridors. From 2020 to 2022, I participated in planning the innovative R&D program for green ship technology and setting up the first national plan with officials of the of the Ministry of Oceans and Fisheries. I'm in charge of the green ship certification program from 2021 to the present at the COMSA. The United Nations Convention on the Law of the Sea is an international consensus about maritime transportation, protection of the marine environment, etc. As you know, it originated from Mare Liberum, written by a Dutch jurist, Hugo Grotius. Mare Liberum stipulated that every nation is free to travel to every other nation. And it also gives us the principle of air and sea are common to all. Based on this premise, we know that every ship is free to navigate to every other sea. We are here today in this program because climate change due to shipping business is common to us. Let me introduce the promotion strategy for eco-friendly domestic vessels in the Republic of Korea. This slide shows the content today. After the background, let me explain the technology development, test infrastructure, and Green Ship K project in the first half. The remainder will give the green fuel supply chain, market activation, and expected effects. First is a background. The Republic of Korea executed the Act on Development and Popularization of Green Ships in 2020. This law defines 6 types of green ships that have lowering emissions, improving energy efficiency, green fuel propulsion, electric propulsion, hybrid propulsion, or fuel cell-based propulsion. What is green fuel? LNG, CNG, LPG, methanol, hydrogen, ammonia. We will understand what technologies make a ship eco-friendly if we depict the juristic definitions on a drawing page. A vessel may use these technologies according to the ship type and use. If you would like to reduce nitrogen oxide or sulfur oxide emissions, you need to have selective catalytic reduction or scrubber respectively. If you want to reduce carbon dioxide emissions, green fuels or energy-efficient technologies may help you. Suppose you have an existing vessel for international shipping, you may have to check whether the vessel satisfies the IMO rules or not. If your vessel does not satisfy the rule, you must take one of the energy-efficient technologies or modify your engine. Let's make the concept of green ship clear again. This is a conceptual vessel for carrying liquefied hydrogen tanker for the Republic of Korea. Do you think she is a green ship? If you can say yes, the ship may have eco-friendly engines for propulsion power. I mean, the concept of green ship is based on the propulsion system, not clean cargo. According to the law, the Minister of Oceans and Fisheries and the Minister of Trade, Industry and Energy formulate the national plan every 5 years. This plan shall have the R&D roadmap, long-term objectives, green fuel infrastructure, etc. The first national plan was publicly announced. It's named the 2030 Green Ship K Promotion Strategy while containing the requirements in December 2020. The government of the Republic of Korea tried to invest $870 million in the innovative R&D program for Green Ship K. After the feasibility study, the government secured about $200 million in 2022. The project organization began to execute their R&D program for 10 years. Step by step, we can have the technological capability for sustainable green shipping. The government of the Republic of Korea announced net zero with the transition toward a low carbon and green economy in 2020. There are several topics: green transition of infrastructure, low carbon and decentralized energy, and innovation in the green industry. Herein, the green mobility is a crucial element, becoming green ship in the marine sector. Three goals of the technology development are carbon-free, low carbon, and localization of the core technology. As you know, a large number of carbon dioxide comes from hydrocarbon fuel. To reduce CO2 emissions, alternative marine fuels like LNG or ammonia will be used step by step. Finally, we are going to have zero-emission technology by use of hydrogen, etc. The hybrid propulsion and full electric power systems are also considered for coastal vessels. A fuel mixture will be available to decrease the carbon intensity in the shipping business to fill in the gap between hydrocarbon fuels and carbon-free fuels. The developed technology will be the basis of verification, validation, and inspection. This technical know-how becomes an interim guide for the IMO agenda and ISO standardization. South Korea already has many test facilities for brand new hull form, electric propulsion, green fuel, and cryogenic service. These facilities will be upgraded according to the market needs. Please visit one of the facilities during the Korea Maritime Week. You may feel how the South Korea is going to be ready. We have several projects for the demonstration. It is classified into marine test bed and flagship vessels. As you know, maritime business is very conservative. It means the entry barrier is relatively high for brand new technology. Even though you have a good product, it will not be simply commercialized if you don't have any track record at sea. The marine test bed will make the entry barrier low through real-time operation. The CRISO will plan the marine test bed supported by the Ministry of Oceans and Fisheries. There will be a lot of technological combinations on board the marine test bed for feasibility. A single test set may consist of alternative fuel, propulsion, and a power source. The result of this real-time test will be given to a developing engineer and user. Another demonstration is building flagship vessels. The full electric ferry was developed successfully. She was launched at Mokpo, Jeollando in 2022. This vessel has a stationary battery as a power source in the first step. The mobile energy storage system may substitute the stationary battery in the second step. If you have any questions about this project, please ask Dr. Young-Sik Kim. He is in charge of this project. This full electric ferry may operate for the service route of island area. The mobile energy storage system does not only propel the ship, but also provide electric power to the island areas. Each energy storage system has about 800 kilowatt capacity. You can see the connection between the mobile ESS and the energy management system. Usually, two onboard ESS may provide the electric power of ship operation. This slide shows the operational concept of a full electric ferry. The regional charging station, delivery by road transport, battery on board, ship operation are a single cycle. I believe this vessel may be quite promising for the small island as domestic transportation. A green ship necessarily consumes a green fuel like LNG. The South Korean government would like to supply LNG as marine fuel for 140 million tons annually up to 2030. A 500 cubic meter class LNG bunkering shuttle will provide the LNG fuel for coastal vessels. On the other hand, a large amount of LNG service is available for the LNG-fueled vessels at Busan and Ulsan. The Korean shipping companies operate the LNG bunkering vessels about 7,500 cubic meter. Market activation. The market sector will be separated into public and civilian sectors. According to the Act on Development of Popularization of Green Ships, the public sector must purchase a green ship when they need it. On the other hand, there is no duty to purchase a green ship in the civilian sector. But if a shipping company buys a green ship, the company may have some financial incentive. Up to 2030, the 528 vessels will have eco-friendly technologies. For market activation of the civilian sector, the green ship certification program is going on. The administrative process is shown in the slide. The applicants may start from the pre-certification or green ship certification, depending on their own condition. In the civilian sector, ship finance utilizes this certification process in compliance with the K taxonomy. For facilitating the eco-friendly technology development, the green ship's equipment certification is also going on. The equipment manufacturers can apply for the process. The refrigerative equipment is a dual-fuel diesel engine for power generation. In addition, waste recovery system may help you to improve your energy efficiency as well as to reduce carbon dioxide emission. This administrative process is linked to the Green Ship Certification Program. At the present, 62 shipping routes are considered as green shipping corridors. The Republic of Korea and the United States agreed to set up the green shipping corridors between both countries. A green shipping corridor is a route between two or more ports where zero-emission shipping solutions are demonstrated. This is achieved through the advancement of technological, commercial, or regulatory initiative along the route. The Korean government expects that a zero-emission merchant vessel is available for this green shipping corridor from 2027. The Republic of Korea has planned for technology development, test infrastructure, demonstration, green fuel supply, market activation, etc. It gives a win-win relationship between Korean shipbuilders and shipping companies. This slide illustrates the ecosystem of the Korean eco-domestic vessels. You can onboard a full electric ferry or a hybrid powered boat. When an LNG-powered vessel demands a fuel, the LNG bunkering vessel will fill the fuel tank as ship-to-ship bunkering process. A famous English proverb is "action speaks louder than words." The Republic of Korea is taking action to keep its promise. Soon after, we can see many green ships around the Korean peninsula. We have been threatened due to climate change. For freedom from the threat, we have to work together actively. What is meaning of freedom? I believe myself with full confidence that freedom means what we do fishing in our native water and inhaling our native air. For to enjoy freedom, we shall follow net zero. As an ordered state, we shall take the green ship and green shipping at whatever cost we have. The Korean policy may be also beneficial to the global society for reducing greenhouse emissions and achieving the net zero in 2050. Thank you very much for your attention.
The various ideas on eco-friendly green vessels have been truly insightful. Thank you, Dr. An, for your presentation. Now that all three presentations of the session 2 have been completed, we will move on to the Q&A session and discussions on future cooperation. Please welcome Dr. Young-sik Kim, Director of the Alternative Fuels and Power System Research Center at the Korea Research Institute of Ships and Ocean Engineering, KRISO, who will serve as the moderator of this session along with our three speakers. May I kindly invite all four of you to come up to the stage.
Okay, thank you. Thank you for sitting the chair again. And then it is honored to be moderate of this session 2 of the Small and Medium Ship Safety Forum. This session focuses on decarbonization from policy support to practical application on domestic vessels. We heard 3 insightful presentations today, each addressing a critical aspect of safety, technology, and policy in the era of maritime decarbonization. Now, let us begin the discussion on the way forward for future cooperation. I will briefly summarize your presentation. Okay. The first presentation of this session was delivered by Mr. Akalu Torbjørn Ruge. Am I right? Okay. From the Danish Institute of Fire and Safety Technology under the title Fire Safety for Future Challenges in Maritime Decarbonization. In his talk, Mr. Ruge started from the introduction of DVI and emphasized that as the shipping industry transitions to greener fuels such as batteries, methanol, and hydrogen, new fire risks emerge that require updated safety strategies. The presentation highlights how these fuels each have unique fire characteristics and the importance of developing advanced fire prevention, detection, and suppression technologies tailored to them. Additionally, it stresses the need for thorough through crew training and international regulatory alignment. Through rigorous testing and research, DVI supports a safe and effective green transition in maritime operation. Okay, the second presentation of this session was given by Mr. Arne Brattore. Okay, from the Norwegian Maritime Authority under the title 10 Years of Ships with Large Battery System, Facilitating Experience and Regulations. His comprehensive talk provided valuable insight into a decade of experience with large battery-powered vessels, covering the Norwegian government's strong policy framework, the ENOVA subsidy program, key safety challenges, incident case studies, and the evolution of regulatory frameworks. His emphasis on crew training, emergency preparedness, and technology-neutral regulation highlighted regulations highlighted the critical steps needed to ensure operation with acceptable safety level of battery system on ships. This knowledge greatly contributes to advancing sustainable and safe maritime electric propulsion, especially for small and medium-sized vessels. And then the third presentation of this session was delivered by Dr. Jung-gun An, titled Policies Promoting the Adoption of Eco-Friendly Domestic Vessels in the Republic of Korea. In his presentation, he introduced South Korea's comprehensive policies aimed at accelerating the adoption of eco-friendly vessels domestically. The presentation highlighted Korea's ambitious national plans aligned with the 2050 carbon neutrality goals, featuring innovative projects such as the Green Ship K, marine test bed, and then pioneering full electric car ferry, which are run by me. And then it also covered the expansion of the clean fuel infrastructure, including LNG bunkering, the establishment of rigorous certification system for green ships and equipment, and government incentives to promote market activation. These efforts collectively position South Korea as the proactive leader in the global transition towards sustainable and low-emission shipping. Okay, so now the floor is open to the question and discussion. If you have question and comments for those presenters, please raise your hand. Yes, please.
예, 잘 들었습니다. 저는 지금 현재 조그만 조선소에서 근무하고 있는 사람이고요. 전반적으로 이제 좋은 프레젠테이션을 들었다고 생각을 합니다. 예, 얘기를 들으니까 요즘에 IMO에서 GHG 프레임워크가 완전히
Not yet. He didn't point out. Yeah, he didn't point out which person goes to answer the question. So, yeah. 예, 계속해 주세요.
예, 저는 조선소에서 현재 근무하고 있는 사람이에요. 예, 근데 요즘 들으니까 IMO의 GHG 프레임워크에 이제 연기됐다고 그래요. 예. 미국을 비롯한 여러 나라에서 반대를 해가지고 그것이 연기됐다 이거예요. 그러면 이제 이 현재 가는 넷제로 프로그램이 좀 뭔가 문제가 있는 거 아닌가 이런 생각이 들어요. 그래서 한국의 스탠스는 뭔지는 잘 모르겠어요. 근데 어쨌든 간에 그쪽의 얘기를 들어보면은 이 글로벌 워밍이 그 사람들이 지금 현재 주장하는 거하고는 좀 다르다 이거예요. 그래서 반대를 한다 이런 얘기를 들었습니다. 좀 신문에서도 좀 보고. 그래서 그런 데 대한 좀 의문이 생겨요. 그래서 지금 해운계에서 내뿜는 CO2가 3% 이내로 알고 있거든요. 그렇게 제가 읽었습니다. 그런데 그 2.8%가 되는 그 CO2 배출의 해온의 양이 다른 산업계와 비교해서 뭐 예를 들어서 항공업계다 뭐 이렇게 그래가지고 어느 정도의 수준에 있는 건지, 예? 우리가 전체 산업에 닿으면 중간인지 해운계가 밑인지 아니면 저 위인지 그 내뿜는 양이 그걸 모르겠어요. 그래서 우리가 그 전체적인 흐름을 저는 좀 이해하고 싶은 거예요. 그래서 아무라도 좋으니까 좀 대답을 해주면 좋겠고요. 그다음에 이제 그 첫 번째 말씀하신 스피커한테 그 듣다 보니까 그 이제 컨테이너 쉽에 그 화재를 디텍션해 가지고 방지할 수 있다 이런 거를 말씀하셨는데 실제의 그러한 그 현재의 어떠한 식으로 그거를 컨테이너십에서 발견을 해가지고 그걸 이제 디텍션 해가지고 파이어 파이팅을 할 수 있는지. 왜냐하면은 컨테이너십의 그 화재는 제가 알기로는 되게 자연 발화로 알고 있거든요. 그래서 그런 것까지도 해결을 할 수 있는지 그 좀 의심스러워 가지고 질문을 드리고요. 그 다음에 두 번째 스피커한테는요. 예. 그 이제 배터리로 운영하는 선박들이 지금 좀 작은 배들이 이렇게 시작을 하고 있는데 배터리의 그 에너지 축적량 때문에 한계가 있을 거라고 다 얘기를 해요. 대형선으로 가지 못할 것이다. 이렇게 얘기를 하거든요. 그래서 지금 초기 단계 같은데 현재의 그 배터리로 운영하는 그 현재 유럽에서 운영하고 있는 선박들이 아까 그 발표로는 뭐 건축의 80%가 밖에 안 된다 이렇게 얘기를 했어요. 그 코스트가 그 짓는 그 코스트가. 그런데 전체적으로 그 경제성을 볼 때 어떻게 될지를 좀 말씀해 주시면 좋겠어요. 그러니까 한 10년 정도의 운영을 한다고 보면 배터리는 그 되게 못 쓰게 되거나 다시 갈아야 되거든요. 그러니까 이제 그런 면에서 경제성이 어떤가도 한번 듣고 싶어요. 예, 이상입니다.
Yes, he has three questions. Yeah, and then the first one is general contents about the decarbonization, and then second one goes to Mr. Luge, I think, and then the third one will go to Mr. Brettler, and then for the first one, Dr. Jungonan, can you say something for that?
Let me speak in Korean because I'm very famished, so I have to translate my language from Korean to English. So I think I have to say in Korean is better. 그 말씀하신 대로 그 1년 정도 그 투표 그러니까 결정을 연기하는 거는 제 기억에 아마 지난주 토요일 날 아마 런던 시간 금요일 날 지난주 금요일 날 제 1년 정도 연기되는 걸로 저도 기사는 봤습니다. 근데 이제 말씀을 해주신 것처럼 온실가스 효과에 대해서 이제 그런 현상에 대해서 이제 그런 얘기가 있는데 교과서적으로 일단 보면 제 기억이 가물가물하긴 한데 온실가스 효과에 대해서 처음으로 검증한 사람은 아레니우스입니다. 아레니우스가 이제 그때 당시 아마 카본 다이옥사이드를 가지고 이제 온실가스를 검증을 했는데 효과를 이제 그리고 나서 실제로 그 IPCC 리포트나 이런 걸 보면 현상적으로 기온이 올라가는 거는 맞습니다. 그거는 제 학자된 입장에서 그거를 좀 뭔가 반박할 수 있는 거는 사실 저는 잘 모르겠습니다, 개인적으로. 그런데 히스토리적으로 보면 저 개인적인 생각입니다만 여태까지 IMO 정책은 어떻게 해서든지 갑니다. 그러니까 이제 뭐 우리말로 뭐 만절필동이라는 말이 있죠. 예, 그 황허는 1만 번을 굽이 쳐도 결국 동쪽으로 흐른다라는 말이 있는데 그런 거 비슷하지 않을까라는 생각은 듭니다. 그러니까 딜레이는 있더라도 결국 그 가는 방향은 좀 이미 정해져 있지 않을까 않을까라는 생각을 해봅니다. 이상입니다.
예. 저도 역시 한국말로 좀 부연 설명을 드리면 아까 CO2 배출량에 대해서 좀 문의 주셨잖아요. 전체 CO2 배출량을 국제기구에서 예측하는 바로는 한 3% 이내에서 얘기를 하고 2.8%에서 3.1% 사이를 왔다 갔다 배출량이 나오고 있는데 사실 그 양이 대한민국 총 배출량보다 많습니다. 대한민국이 한 2.4%에서 5% 정도 배출을 하고 있는 상황이거든요. 그래서 한 국가보다도 그것도 세계 경제 10위권 안에 드는 한 국가보다도 많은 배출량을 쉬핑 인더스트리에서 배출을 하고 있기 때문에 그만큼 환경에 영향을 주고 있다고 저희들이 좀 예측할 수 있는 부분이 있어서 그 양이 좀 상당히 좀 많이 있다는 말씀을 좀 드릴 수 있겠고요. 일단은 그 다른 그 운송 수단과 비교를 하면 항공기가 그 쉬핑보다는 약간 적고요. 그 기차가 가장 적고 가장 많은 거는 어쩔 수 없이 가장 대수가 많은 자동차 분야에서 CO2가 가장 많이 나오고 있습니다. 근데 각 산업별로 CO2 배출을 줄이기 위해서 자동차 분야는 뭐 유로 6라든가 다양한 어떤 법적인 제재 조치들을 통해서 이제 CO2 배출을 점점 줄여가고 있는 상황이고요. 그러한 것에 발맞추어서 항공 분야나 어떤 그 기차 분야나 그다음에 이제 쉬핑 분야도 우리 선박 해운업도 그런 방향으로 가고 있어서 전체적으로 그 방향으로 가는 건 맞다고 좀 얘기 드릴 수 있을 것 같아요. 하고 이제 그 아까 그 안중건 박사님 말씀하신 것처럼 지금 그 우리가 그 IMO 디카보네이제이션을 안 가겠다고 선언을 한 게 아니고 몇몇 국가들에서 이 부분에 대해서 조금 더 고민을 해보자는 입장에서 1년 정도 투표 기간이 더 연장됐다고 말씀을 드려야 될 것 같고요. 그러한 부분들이 지속적으로 좀 논의가 필요한 내용이 아닐까 싶습니다. 왜냐하면 변화가 굉장히 빠르게 이루어지고 있는데 그 변화에 대한 속도 조절의 문제가 아닌가라는 생각이 좀 들어서요. 그런 부분들은 좀 조금 더 좀 추이를 지켜보고 우리들도 좀 생활을 해야 될 것 같아요. 근데 이제 개인적으로 느끼는 부분은 올 여름 너무 더웠습니다. 작년 여름도 너무 더웠습니다. 내년 여름은 더 더울 것 같습니다. 이러한 분위기들이 지속적으로 간다면 우리가 환경을 위해서 뭔가 역할을 해야 되는 부분은 당연히 해야 될 부분이 아닌가 싶습니다. 이 정도로 좀 그 일반적인 말씀을 좀 드릴 수 있을 것 같고요. Okay, let's answer this for the question from the floor. Yeah, Mr. Luge, please.
Check. Yes. Thank you for the question. So I'll attempt to address the question on container fire safety and detection. So you could say, to summarize the issue, the industry has moved in a direction where you have incredibly large vessels which follow the regulation of something that was originally much, much smaller. Which means you have large cargo holds and many containers on deck, up to maybe 7, 8, 10 tiers, and not a very large crew. So that is one issue. Secondly, you have the container itself as an intermodal mode of transportation, which inherently in practice means that you have no idea what is in the box. Regardless of declarations and best intents and sometimes worst intents of misdeclarations, from a practical standpoint, you have to assume that a fire can start at any given location on the ship, if we talk cargo fires, because you cannot know what is inside the container. On the ship itself, you have several issues. You have the issue in the hold that you have a regulated detection system, which is the smoke extraction system. This system is very faulty in terms of creating you could say, an early detection. First of all, the smoke needs to leave the box. That can take many hours. Then the smoke needs to come into the cargo hold, which is sometimes ventilated. If it contains reefer containers, it might have quite a large airflow. That means it takes even longer. Sometimes the smoke extraction system draws from several holds, which means you have an even longer detection time. So you could say inherently current detection systems in cargo hold is late. That is a fact. Detection systems on deck is non-existing in the current state of things. That is reliant on crew observation. Detection is not the only issue because firefighting measures are not very effective either. You could say on hold, you have again a system which is the CO2 system. This time it relies on CO2 actually entering the container to choke the fire, and we have seen repeatedly that this fails probably 50% of the time. On deck, you have a lens, if you follow only the current SOLAS prescription, a lens that is not very suitable to penetrating a container, and it is relying on early detection, which you inherently do not have, because you're relying on only crew detection. So that's a lot of issues. A few years ago, we did the study for EMSA called CargoSafe. That's publicly available on the EMSA website. This was submitted to the IMO, went through the FSA process and the FSA review, and is currently being treated in the SSC subcommittee in the fire protection group. It's been ongoing for a few years now, and the DMA and DBI is very, very active in this, and we're currently working on updating these. That being said, anything IMO is also political, so certain things you can say follow the lowest common denominator, so that is not to say that these are the only solutions. There are many solutions to this problem, but sometimes you have to go maybe above and beyond if you want to do something different. And there are certainly solutions, and I would love to discuss them with you if you are interested.
Okay, thank you. Please go third question.
Yeah, okay. If I understood it correctly, it was in regards to scaling on larger ships. I don't know if that was there, but I want to say with batteries, it's more depending on the operation mode of the ship, more than the size. If I'm a small ship that goes out and I'll stay out for weeks, then batteries isn't your energy source. Mr. Ruge showed what is going to be the largest battery vessel from Denmark in 2028. We are having some projects with Solas Ropax vessels, which will be even larger. So it depends on the operation of the vessel, more than the size. When it comes to the cost, that's not my field of expertise, but what I can say is that the first example, Ampere, given all the support scheme it got in the beginning, and it's a public tender, so it's paid for by the state anywho. Changing of the batteries will not be impossible. It will be economically sound for that vessel. Yes, thank you.
Okay. Because of the lack of the time, I just have one question for Mr. Boratule. I know Norway is first mover for the electric ships, especially for domestic vessels. What has been the most effective policy in Norway? Norway's successful operation of carbon-neutral coastal vessels.
I would say it's obviously public tenders. Public tenders is why we have that many electric ships. But when you do it that way and you scale up your industry, you scale up your battery suppliers, you scale up your integrators, then it becomes economically viable for the private sector. So one of the largest, or the Incat, not the ship, but the Solas vessel that is going to go between down in South America, a very large ship, 40 megawatt hours. It's from a Norwegian battery supplier, and that battery supplier sort of has risen based on the public tender. So you make a whole industry, and you make the economy around it, and you make it economically sound.
What about the subsidies?
Sorry?
Subsidies. What about the subsidies? The Enova has
obviously to get it into the private sectors and to promote innovation, then Enova is fantastic. But for the main part, it is the public tenders in Norway at least. But Enova is helping promoting that to the rest of the segment as well. Yeah. For example, the fishing vessels, and what we have a lot of in Norway are these small work boats for the fish industry, I don't know the word for it, but the salmon, which the Norwegian salmon, which yeah.
Okay, this concludes the session 2 of the Small and Medium Ship Safety Forum. And then on behalf of the organizing committee, I would like to thank you all the speakers for their contributions and thoughtful perspective. Let us continue to collaborate in building safer and more sustainable seas for the future. And then this is the end of the discussion of this session. Okay, thank you.
Thank you so much. Please give a big round of applause to today's moderator, Dr. Kim from CRISO, and to our 3 speakers. And now we are taking a short moment to arrange the venue. Once everything is ready, we'll proceed with the final part of the program. Thank you so much for your proceed to the closing ceremony, the final part of the Small and Medium Ship Safety Forum. Mr. Donggun Lee, Executive Director of Maritime Transportation Division at KOMSA, will deliver the closing remarks. Please welcome him again with a warm round of applause.
네, 장시간 동안 수고 많으셨습니다. 준비한 피해사를 읽도록 하겠습니다. 이 자리에 모이신 우리 귀빈 여러분, 그리고 또 발표하시고 발표 내용을 또 들어주시고 또 많은 논의와 또 질문을 하신 참석자 여러분께 오늘 하루 열정적인 발표와 그리고 또 활발한 논의를 통해 이런 뜻깊은 논의의 장을 함께 만들어주신 모든 분들께 진심으로 감사의 말씀을 드립니다. 오늘 포럼을 통해서 각국의 전문가들이 연안 중소형 선박의 디지털화 그리고 탈탄소화를 주제로 정책과 기술의 경험을 공유하고 보다 또 스마트하고 또 지속 가능한 해양 안전 체계의 방향을 함께 모색할 수 있었던 그런 자리였던 것 같습니다. 특히 오늘 논의된 내용들은 대형성 중심의 어떤 기존 국제 규제의 범위를 넘어서 국민의 생명과 일상이 아주 밀접하게 연관되어 있는 우리 중소형 선박의 안전성 강화라는 실질적이고 시의적절한 그런 어떤 과제를 중심에 두고 있다는 점에서 큰 의미가 있다고 하겠습니다. 디지털화는 중소형 선박의 운항 데이터를 기반으로 예방적 안전관리의 가능성을 오늘 제시를 하였고요. 그리고 또 기후변화 대응과 해양 안전이 서로 보완이 되는 가치임을 또 탈탄소화를 통해서 저희들이 알 수 있었습니다. 이러한 논의가 향후 협력을 통해 구체화되기를 기대합니다. 국내의 전문가분들께서 공유해 주신 다양한 사례와 협력의 방향에 대한 제안을 안전하고 지속 가능한 바닷길을 만들 수 있는 실질적인 동력을 제공하리라고 저는 믿습니다. 우리 공단은 연안 중소형 선박의 안전과 지속 가능성을 높이기 위해 앞으로도 정부 그리고 산업계, 연구기관 등 국내의 다양한 계층의 이해관계자들과 파트너십을 강화할 예정이며 이번 중소선박 안전기술 포럼을 통하여 그 성과를 같이 공유할 수 있기를 희망합니다. 오늘 포럼에서 나눈 지혜와 성과가 각국의 정책과 현장에서 확산되고 더 안전한 친환경적인 바다를 만드는 밑거름이 되기를 진심으로 기원합니다. 끝으로 바쁘신 일정에도 불구하고 오늘 포럼을 빛내주신 발표자 여러분과 그리고 또 토론자 여러분, 그리고 현장과 온라인으로서 함께해 주시는 모든 참석자 여러분께 깊은 감사의 말씀을 드립니다. 여러분의 건강과 행복, 그리고 앞으로 성공적인 활동을 기원드리며 이상으로 네 번째 맞이하는 중소선박 안전기술 포럼의 모든 일정을 마치도록 하겠습니다. 감사합니다.
Thank you, Mr. Lee, for your wonderful remarks. This concludes all the programs of the Small and Medium Ship Safety Forum. We would like to express our sincere appreciation to all participants for taking the time to join us today. We look forward to your continued interest and participation in future editions of the Small and Medium Ship Safety Forum. Now, I'd like to make an announcement regarding lunch. Today's lunch venue at the Yongbin Gwan building is Ruby Hall on the first floor. Lunch will be served from 12:30 p.m. to 1:30 p.m. Once again, lunch will be available at Ruby Hall on the first floor. Please enjoy your meal, and we hope you will also take interest in the other events of the 2025 Korea Maritime Week taking place this afternoon. This was Seun Myung, MC for today's forum. Thank you for everyone.